Hi everybody, in today's video I'm gonna show you how to solve the task which is about to determine the standard form of the quadratic function given by the graph. I'm gonna show you two cases. The first one is easier than the second one because there is no need to modify the quadratic function, because all the points will be set by defining the vertex and by defining the vertex form of the quadratic function. So in this case we have the function given by the graph on the left side, and the most important thing in this case is to realize that the vertex of my parabola is in a point 4 and a -7 is for x and -7 is for y. As we already know, the function should be or could be given in this way, that y equals x take away 4 squared minus 7. This is almost like 100% sure that this is my function, but as the requirement is to have the function in standard form, we have to simplify this expression and to provide the function in a times x squared plus bx plus c. So we will have to simplify this expression, which is x take away 4 squared is x squared minus 8x plus 16 minus 7, which will lead to the function x squared minus 8x plus 9. The only thing I have to verify is that there is at least one point which is part of my function and it fits to this definition. So the easiest way is to take this point, which is, let's say, point A, and its coordinates are 0 and, as you can see, 9. So as this point must belong to the function f, we simply have to check if our equation 9 equals x squared, which is 0 squared, take away 8 times 0 plus 9 is true. Why 0 squared? Because x for this point is 0, and we simply see by simplifying this or solving this equation that 9 equals 9, which is true, and it would mean that point 8 belongs to the function f. So my final decision or my final solution is that really the graph of this function is given by y equals x squared take away 8x plus 9. So this is my solution. Okay, now let's see what will happen if we have a little bit more complex graph and we will have to modify our vertex form of the quadratic function. Let me just erase this and take the graph of another function which will be like not solved so easily. So let's remove this graph and let me take the second graph, which will take a little bit time. Okay, let me put it here and let me just make it a little bit smaller so that it fits on my screen. So now in this case the procedure is same. We have to realize that our vertex of our parabola is in has the coordinates 4 and 10, okay, which would lead to definition of my function y equals x take away 4 squared plus 10. We already know that x take away 4 means that our parent function is moved to the right of 4 points, and plus 10 means that our vertex is moved, or moved 10 points up. So this would basically be any parabola which will go through vertex with the coordinates 4 and 10. Now, in this case, we really have to realize that our parabola is not opening up, but it opens down, which means we have to modify our function being y equals negative x minus 4 squared plus 10. Because if it would be plus here, then our parabola must be in this shape, so it must be opening up. But as we can see in our case, the parabola opens down, or we simply can say it's concave. Now, there is only one thing we have to check, that really there is at least one point, and in this case we will take this point, and it's point 8 with the coordinates 0, which is, by the way, the intercept with the y-axis, and it is negative 21, 22, 23, 24, 25. So it's 0 and negative 22. This point must belong to our function. So let's find out if this point really belongs to the function we have defined a couple of seconds ago. Which means negative 22 stands for y, so negative 22 must equal negative x minus 4. In this case, x is 0, so it's like 0 take away 4 squared plus 10. Which means negative 22 must equal to negative 4 squared is 16, so negative 16 plus 10, and as you can already see, negative 22 doesn't equal to negative 6. Which means if we would have our function defined by this relation, then point, which is clearly part of our function, will not be part of the function. So we have to find some parameter, and as I showed you during the lesson, there is some kind of parameter q which we have to find out, and this parameter q is stretching or shrinking our function. So let's find out what is the number of what is q in our case. To find out what the q is again simple, because we have to be sure that a point with the coordinates 0 and negative 22 is the part of the function, which means we will come to the equation negative 22, which stands for y, because it's point of our function, must equal to negative q times x, but in this case x is again 0, so we will have 0 minus 4 squared plus 10. So this will lead to the equation negative 22 equals negative q times 4 squared is negative 16q plus 10, and this is like really simple linear equation, which means you take away or minus 10, which is negative 32, equals negative 16q. Now you multiply the equation by 1 over negative 16, which I can write this way, but it's more obvious, it's more simple to write it times negative 1 over 16, and this would lead to q equals 2. Okay? Making the conclusion of all these points will lead us to the definition of the function f must be like y equals negative 2 times x minus 4 squared plus 10. This would be our final decision or final definition of function f, but let's do some checks. For example, let's try and let's be sure that this is really the function we are looking for, and this is the function of the graph given on the left side. So let's try again. -2 must equal -2 times 0 take away 4 squared plus 10, which means -2 equals -2 times 16 plus 10, which is really -2 equals -32 plus 10 is -22, which means our point A is really part of the function. We could simply check again above or for the vertex, but as we already constructed the description of the function in a vertex form, we are quite sure that our function is passing through that point. We can find any other point on our graph and make the calculation or check, but as we were supposed to write the function in standard form, and as we know this is a vertex form of the function, we have to simplify the expression on the right side so that it is in the form of a times x squared plus bx plus c. So our final function will be like y equals -2 times x squared -8x plus 16 plus 10. Let me just make it a little bit longer. So my function will be -2x squared plus 2 times 8 is 16x. This is gonna be like -30. Okay, let me do it like really in details. So my final function will be -2x squared plus 16x take away 22. So this is the solution of my task, like the final one. This is the function which is represented by the graph of the left side, which is the parabola given at the very beginning of my task. Okay. If you would have any further questions, just write your comments. Thanks for watching.